Hello and welcome everyone. Very happy that we are all together again. In this tutorial we will start learning about the lighting systems and its manual designing steps. So fasten your belt and let's get started. The aim of this tutorial is to start learning how to design any lighting system. So we need to know what are the different steps of designing the lighting system, as we will start constructing the lighting systems using the manual calculations. So let's go ahead. First of all, we need to say that for the manual lighting system design, there are some manual steps we use for designing any lighting system. And the first step of them is to detect the total number of luminaires required for any place. So if we have a room and we need to make a lighting system for that room, the first thing we will do is to calculate the total number of luminaires which we will use in that room. Also, the second step is to detect the shape of the luminaires distribution. This is because if we decided that we need, for example, 6 luminaires, this will not be enough, as the number of luminaires can have different shapes of distribution across the ceiling of the room. So one distribution strategy is to spread the luminaires along the width of the ceiling. So if the luminaires are put across the width of the ceiling, this will be one strategy of distribution. Also, another strategy of distribution is to spread the 6 luminaires across the length of the ceiling. So we can spread across the length and we can spread across the width for the same number of luminaires. And there may be some other methods of distribution of the luminaires, but anyway, those are the steps of designing, which are to detect the number of luminaires and then to select the suitable way of distributing them. Alright, now we need to know in some details how can we calculate the suitable number of luminaires required for any room. Here we say that the required number of luminaires is calculated from this equation. Here n equals E times A over phi times LLF times UF. As you see, n is the number of luminaires required for that room, so it's the final aim that we need to reach, which are the required number of luminaires. And then in the numerator we have E times A, where E is the value of the illumination or lux required for that place or that room. If you remember, we learned it before that the illumination or the lux is the amount of light that we will supply the room with. And this amount of light that the room will need depends on the type of the room itself, as each type of room will need a specific amount of lux according to the nature of the room itself or the application that we need the room for. For example, some rooms will need a larger amount of lux or it needs higher illumination. This is because the type of the application that we will use the room for needs larger lumens, like the reading room, as it needs larger lux for reading. On the other hand, some other rooms need smaller amount of illumination or lux, like the sleeping room, as it needs to be more calm or to have more relaxation, so its amount of lux will be smaller. And we detect this value of lux from some codes, which may be an international standard code or it may be a national code like your country code. And this is an example of the required amount of lux needed for some different rooms according to their type. You can see the living room needs 50 lux, and for example for the bedroom it needs 150 lux, and also for the bathroom it needs 100 lux. So according to the room type, we detect the lux. Very good. Now the second factor in this equation is A, and A is the room area simply. So to detect the number of luminaires, we multiply the lux of the room by the room area. And the room area equals the room length times the room width. So we must know what is the area of the room to detect the required number of luminaires. Alright, that's for the numerator. Now for the denominator, the first parameter we have is phi, or the flux, which we illustrated before. Here phi is the luminous flux of the luminaire, and it depends on the amount of light that is going out of the luminaire itself, so it depends on the luminaire. As it's the lamp light intensity, so it's the intensity of the light out of the lamp. And we detect this value from the datasheet of the lamp. So once we decide that this type of lamp, or we will use that type of luminaire, we open its datasheet and we detect the luminous flux from it. For example, this LED lamp has a rated luminous flux of 600, so we will substitute with 600 in this equation, or we will substitute with 600 instead of phi. Very good. Now the next factor we have is LLF, and LLF is the light loss factor, or the maintenance factor, and this factor is used to detect the losses in the light out of the luminaire, as there will be some losses in the light, so we need to put those losses in consideration to compensate those losses. And to detect this factor LLF, we find it to be the multiplication of 6 other factors. Here LLF equal LLD times LDD times LDF times RSDE times LPO times VVF. But we need now to know what is each of those 6 factors. Here, the first factor of them is LLD, or the lamp lumens depreciation, and it refers to the performance of the lamp, or the lumens out of it across its life. This is because the lamp's performance changes when its time passes, or the number of lumens out of the lamp is not a constant one across its time, but the lumens of the lamp decreases across its life. And this factor LLD equals the mean lumens over the rated lumens. So we calculate the average lumens compared to the rated lumens that the luminaire is designed to produce. And this value LDD is detected also from the lamp datasheet, so it depends on the luminaire type itself. Very good. Now the second factor we have is LDD, and LDD is the luminaire dirt depreciation, and it measures the amount of lumens that is lost due to the dirt of the luminaire surface. This is because when dirts or dust are accumulated on the luminaire surface, the output lumens will decrease, hence we need to consider this decrease in the lumens output of the luminaire due to the dirt effect. Alright, now the third factor we have is LDF, and LDF is a factor that measures the amount of lumens that is lost due to the dirt of the lamp surface. This is because when the dirt or the dusts are accumulated on the lamp surface, the output lumens will decrease of the lamp, hence we need to consider this decrease of the lumens output of the lamp due to the dirt effect. But you cannot hear that we are considering now the dirt on the lamp itself, while for the previous factor it was for the dirt on the luminaire, not the lamp, as it was the luminaire dirt depreciation. And this is because the luminaire consists of some lamps, and each lamp of them has a surface, and the luminaire itself has another surface, which is the luminaire cover. So we take the luminaire surface and the lamp surface in consideration. So we take both of the luminaire surface and the lamp surface in consideration to measure the amount of dirt or the amount of dust on them. Alright, now the fourth factor we have is RSDD, and RSDD is the room surface dirt depreciation. And this factor is related to the dirt on the surface of the room, as when the room surfaces has dirt on it or has dust on it, this will absorb the lumens out of the lamp and decrease the effect of the light out of the lamp. While when the room surfaces have less dust or less dirts, this increases the effect of the light or illumination, which makes the room to appear more bright. So that's for RSDD. Now the fifth factor we have is LPO, or lamp burn out, and this factor considers the case at which we have some lamps which are burned out of the luminaire, So the ideal case is to have all the lamps on the luminaire to be working, but we suppose the worst case at which there may be some burned out lamps, so the total output lumens of the luminaire will decrease, and for that reason we must increase the total number of lumens to compensate this decrease in the output light due to the burned out lamps. Very good. Now we have the final factor, which is VVF, or the voltage variation factor. And this factor considers that there is some losses in the output light due to the variation of the input voltage. As we know, the lamp input power is the voltage times the current, and its output power is the light out of the lamp. So if the input voltage of the lamp decreases, the output light of the lamp will decrease greatly. And this is because each 1% decrease in the input voltage results in 3% decrease in the output light. So it has a larger effect of decreasing the output light, which is about 3 times the decrease of the input voltage. And for that reason, the voltage is an important factor which we must conserve to have a constant value, not to affect the output lighting system or the output lumens. Alright. Now, after discussing those 6 factors of the LLF, we need to know practically how can we set the value of LLF. As in the practical working, LLF is set with an approximate value according to the case we are working on, and this depends on the maintenance of the luminaire. As in case of there is an irregular maintenance of the luminaire, we will set the LLF with a value that ranges from 0.6 till 0.75. And this means that the luminaire is not checked and maintained regularly. While if there is a regular maintenance of the luminaire, we will set LLF with a value that ranges from 0.7 till 0.9. So this is in case of the irregular maintenance. But you can ask now, how can we set LLF in case of we don't know how the future maintenance will be? So we don't know if the future maintenance is a regular maintenance or an irregular maintenance. Here at that case we will put LLF with 0.8, that is a middle value or an approximate one. So LLF is used practically with 0.8 in case of the unknown case of the maintenance. More than great. So that's about this tutorial at which we started explaining the lighting manual designing steps, and on the next tutorial we will continue illustrating this topic. Hope that's clear right now. Thank you for watching and see you next tutorials.